Hello everyone, welcome to this video. In this video, we'll be studying about the basics of coordinate geometry. Coordinates, first of all, you should know what is a coordinate. Whenever we wanted to define the location or the position of some object, we use numbers and we call those numbers as coordinates, right? For Earth, do you know? To specify the position of some country or some person standing over somewhere, what we require the coordinates, and these are latitudes and longitudes, if you have studied already about them, correct? So these are basically the coordinates of some position on the earth, right? And similarly, for in mathematics, what we do, we make coordinate x's here, some graph here, and define with respect to this scale and this scale what is this position. We'll be studying this in detail. So here we require coordinates, and we have different kind of coordinates with us. One is these Cartesian coordinates, then polar coordinates. In Cartesian coordinates, we use these x and y, right? In polar coordinates, we use this r and theta. In spherical coordinates, we use this rho, which represents some radius or distance only, right? This theta and phi are two different angles, and you'll be studying about them when you study in detail about different coordinate systems when required. Spherical system is useful whenever you have to deal and study about spherical objects like that of a sphere. And cylindrical coordinates, they are helpful when you wanted to study about cylindrical objects, right? So instead of talking about the dimensions and things in Cartesian, it becomes very difficult for you to study about it. Hence we use cylindrical coordinates. Here we have two distance coordinates and one angle coordinate with us, correct? But in this course, we shall be focusing on Cartesian coordinates. So you should remember what are these. We call them as x and y, right? So in order to define Cartesian coordinates, you should first know what is a Cartesian plane. For a Cartesian plane, we have two axes. One is this horizontal axis, which you call as this x-axis, right? Another one is the vertical axis, which you call as y-axis, like this. Whatever is the intersection of these two axes, you call that point as origin, correct? And you have different scales marked here. This is the positive x-axis, this is the negative x-axis, this is the positive y-axis, this is the negative y-axis. Now if you wanted to locate what is the position of this point here, P, you draw a vertical line here such that it cuts your x-axis. So you see at what point does it cut your x-axis? At 4. So this is your point. And distance 4, and if you draw a horizontal line parallel to x-axis which cuts the y-axis at some point, what is this point? This point is 3, so you mark this as y. So you write the points x and y representing the distance along the x direction and the distance along the y direction, correct? Okay, so now if you have 2 points, one is P, another one is Q, right? So you wanted to and the coordinates are given to be x1 y1, x2 y2. Now if you wanted to determine what is the distance between these 2 points, we have a formula which is known as the distance formula. This formula is always positive, that is why we use this bar. Why? Because it tells you the distance, and distance is never negative. Hence, the distance formula is the x coordinate of the second minus the x coordinate of the one whole square, plus the y coordinate of the second point minus the y coordinate of the first point whole square, right? So let's take an example. If I tell you find the distance between you and your friend, how can you do that? Suppose you are standing at the position 5, 4 and your friend is standing at this position -3, -1. Then according to the distance formula, the distance comes out to be equal to 9.43 units. Right? Whatever is the unit here, you can write it down. It could be meter, it could be kilometer, and so on. Similarly, for the next concept, if we are given the coordinates of 2 different points, right, and we have to find the coordinate of a point which divides the line segment joining those 2 points in certain ratio, right? So how can you do that? Suppose we are given some point here as say A, x1 y1, and another point B as x2 y2, and we wanted to cut this line segment at some point P, and we wanted to find out what is our x, what is our y, such that it cuts this line segment at in this m ratio n. So how we can do that? We have a formula for it. The x coordinate here would be given by this formula, mx2 plus nx1 divided by m plus n, and the y coordinate here is given by this formula, my2 plus ny1 divided by m plus n. Now how we can remember this formula? Now it might look quite difficult at first to remember this formula, but you can very easily learn this formula. How? For the x coordinate, when we are calculating it for the x coordinate, you have to multiply the opposite ratio with the opposite x coordinate, correct? If m is here, so you have to multiply it with x2, plus if n is here, you have to multiply it with the x coordinate here, because we are calculating for the x coordinate, and then you can divide it by the addition of this ratio m plus n. Similarly, for the y coordinate, if you have wanted to calculate it for y, you multiply this m with the y coordinate here plus the n with the y coordinate here, and then add m plus n, correct? Now let's look at an example here. We are given the situation that we have two pajamas with us of different sizes, each one for a father and one for the son, correct? Now the mother here that decides to put an elastic band on the waist of both pajamas, right? So here also she wanted to apply an elastic here also, right? And she knew that the waist of father and son, that is in the ratio 2:1, right? Then from where does she cut a large elastic band? Suppose this is the elastic band she has with her. Then from where should she cut? From here or here or here or here? From where does she cut it from, so that she would get the appropriate length? This is the question. Now you can use it using this section formula. How? Let me show you how. First of all, you have to define this elastic band using these two coordinates, right? The coordinates of the end point, that is not given to us. We should take it by ourselves. So what we can do, we can draw an coordinate axis like this. This is your y-axis, this is x-axis. Now what you can do, you can place your elastic band starting from origin up to some length here, right? So because we know it is of 2 meters, because we know this is origin, so we can the last point, because this length is 2, so the last point y coordinate would be 0 and x coordinate would be 2. So the coordinates would be like this. And now we wanted to cut it into 2:1. So we wanted to determine what are these coordinates. So by the section formula, you can very easily compute the coordinates. The coordinates come out to be 4/3 and 0. So the mother that should cut the elastic band at the point 4/3 and 0 from here, right? Okay. Next, we can have this midpoint formula. What is this formula? This formula says if we wanted to now cut the things at equal ratio, so whatever is this much, that same thing is this much. So that is why we are saying it is a middle point, right? So if this ratio is the same, then our formula becomes this: x1 plus x2 divided by 2 and y1 plus y2 divided by 2. How? Because you see, we are cutting it in the same ratio, so we are taking the ratio to be 1:1. Hence in place of m and n, you can write 1 here in the section formula, so that you have this particular formula, correct? This is very simple. Now let's have a look at one question. Now the situation changes. So here the mother wants to determine from where should she cut the elastic band of 2 meters such that she could put elastic on 2 identical pajamas of his son, right? So here that is quite simple. You will cut it from the middle of 2 meters is 1. No need to solve anything, right? We can do it orally. But how on this very simple problem can we apply this midpoint formula? Let's have a look. So first of all, you require the coordinates for this elastic band. So let's again use the same technique. Let's take this y-axis and this x-axis and put our elastic band from origin, so that its coordinates become 0, 0 and 2, 0. Correct? Now we wanted to calculate its midpoint. x and y, such that it cuts it in the same ratio 1:1. So the coordinates for x, they are x1 plus x2 divided by 2, and for y they are y1 plus y2 divided by 2. So when you compute it, it comes out to be equal to 1 and 0. Hence she should cut the elastic band at the point 1, 0, right, when that elastic band was kept at the position 0, 0 and 2, 0. Correct? For the next topic here, we have the area of a triangle, right? Suppose we are given some triangle with the points A, B, C having coordinates x1, y1, x2, y2 and x3, y3. Then the area is given by this formula. But how can you remember such a large formula without any mistakes? So here I have a trick. So in order to calculate the area, what you can do, you can write half here and you can solve this determinant, right? Determinant, when you solve this determinant, actually this is the mod of this determinant, because you will be getting this positive value. Now what you have to do, you know how to solve a determinant, you have to expand it by this first row. So taking x1 here, right, you will multiply y2 into y1 minus 1 into y3, correct? For the next element, you will write minus x2, right, and now you'll skip this and skip this, so you'll be multiplying y1 with 1 minus 1 with y3. That's it. And for the last element here, you will write plus x3, right, and you'll delete this and you will delete this column in row, so that you will have y1 into 1 minus 1 into y2, correct? So this becomes your formula. When you simplify it, you see this is exactly equal to our formula here, right? And this is the modulus. So that means even if a negative number comes, we skip that negative and take only the positive part. So as for an example, let's see this question. Find the area in which a triangular shaped monument is spread whose coordinates are noted as 4, 4, 3, minus 2 and minus 3, 16. So let's first of all draw this coordinate. Suppose this is our x-axis and this is our y-axis. This is origin. So let's mark them, and now what we have to do, we have to find this area. So this area is obtained when you have when you know this formula. So it is half of this determinant. So you can write the x values first, minus 3, 4 and 3. Correct? And then you can write the y values, 16, 4 and minus 2, 16, 4 and minus 2, and then you can write 1, 1, 1 here in the third row. Now you have to expand this determinant, solve it. When you solve it, you see your value comes out to be minus 54. However, we wanted to just take it to be the positive value. Why positive value? Because it is the area. And can area be negative? No, it cannot be negative. So we have our answer as 27 square units, right? So I hope you understood these basic concepts of coordinate geometry. In the next video, we'll be starting with our main concepts from coordinate geometry. Well, that is it for this video. Thank you for watching.